All right, so the first question on the quiz, right, was about, let's see, I'm going to share my other screen here. So it was dealing with adding two rational expressions together. And so some students were trying to kill off the denominator with that. So I wanted to make sure that it's clear that you understand the difference between an expression and an equation, right? Because these are two different things. So an equation, I mean, just like it says, it sounds like it has an equal sign in it, and that's exactly what it is. So it has an equal sign in the question. Sometimes we put, equal signs just to show that one statement that we wrote is equal to another statement that we wrote. But when an equation starts off with an equal sign in it, we know what, an expression equals another expression. So it has an equal sign from the start. And on these type of questions, they'll ask you to solve, right? So when there's an equation, you'll be asked to solve. Where expressions, right, are just when you're adding, subtracting, multiplying, dividing, and they give you the instructions to simplify, right? And so when we're dealing with, so let me write down this first one. So it said 2 over x minus 3 plus x minus 15 over x squared minus 9. Right? So this is an expression, right? Because it doesn't start off with an equal sign in it. We don't know what this is equal to. There's other questions that you have where it would say something like this equals, -5 or something like that, right? And so then that would be an equation. But when we're dealing with these expressions, you have to keep the denominator, okay? You can only kill the denominators if it's an equation, okay? So this is when you can kill the denominators, right, with equations. But you can't do that with expressions. So we are going to find the LCD of this. And the LCD would be found by, well, let's first factor. Make sure both of the bottom terms are factored there. And then we can see that the LCD is going to be x minus 3 times x plus 3. Okay? So now I'm putting this equal sign in to say that I'm making an equivalent statement to the one that I have before, right? But this time, I'm making a common denominator here, so we can get these together. And so I look at my first fraction here, and I see it has that x minus 3 part, but it doesn't have the x plus 3. So I need to multiply the top and bottom both by x plus 3. Where my second fraction already has both the x minus 3 and the x plus 3. So it has everything it needs. Remember, we're trying to get it to look like this new denominator here. Okay? So then when I distribute my 2 through there, I get 2x plus 6. And then I don't need to multiply that x minus 15 by anything, but I do need to combine my like terms together. Right, so the whole idea of this is we're trying to add these two together. A common mistake that I saw is that students were not combining the like terms. After they put the x plus 3 on the top, they canceled it out with this x plus 3 on the bottom. Well, there's a couple of reasons why you can't do that. First of all, we don't want to do that because we're trying to make a common denominator. And if I cross that out, then that's no longer a common denominator. And also this is connected by addition, right? And I can only cancel things out when they're connected by multiplication because that canceling is really, a better way to say it is dividing out, okay? But then if I combine my like terms together here, I'd get 3x minus 9 on the top, and then x minus 3x plus 3 on the bottom, right? I still have to keep that common denominator through it. All right, then I can see on the top that there's a greatest common factor of 3 that could be factored out. And then I see the very last step is where I want to do any simplifying. See, everything now is connected by multiplication, right? 3 times this times this, right? So, let's see, is anybody else getting some bad feedback? Is it coming? I'm not hearing anything. Just make sure everybody's muted. Just double check, make sure everybody is muted. And since everything's connected by multiplication, then we can divide things out, right? So I'm going to go ahead and kill this denominator with that part of the numerator, which will leave me with 3 on the top and x plus 3 on the bottom. Okay, and so that's where I get, keeps freezing up on you. Okay, hold on just 1 second. All right, so let's look at the second question. So this is the first question on the quiz, and one of the questions, you know, similar to one of the questions that you may have had on the test. Number 2 is one of those distance equals rate times time problem. And these definitely were ones where a lot of students seem to struggle, and so I really want to help you understand these better. And so please, like, speak up, like, you know, help me understand, you know, what part of it you feel like you're getting lost in. Okay, so can anybody speak up or tell me what you're thinking about this number 2? Not sure. Okay, so anybody has anywhere to like say kind of what was tricky about it? Because like I said, I think it was only like, I don't know, 60-something% of students got this right on the test, so that was really low. Most of the questions, you know, like people got, you know, 80% or better and got it right. So I was like, wow, that's really low. But okay, so let me just try and, you know, spell out what's happening here, right? So here's a restaurant that these guys are both leaving from, right? One's going in one direction, and then the other person is going in the other direction. And we're trying to figure out when they're going to be 150 miles apart. No, 160, sorry, got it wrong. 160 miles apart. So, but all we know is the rate in which they're going. So I know that, let's see, Fatima is going 35 miles per hour, and Felipe was going 45 miles per hour. And then we know that they left at the same time, so our time is just going to be represented by t. And then the other thing that you got to keep in mind here, since we don't know, you know, which distance each of them went, we just know a total distance together, All right, then we need to think about, oh, well, distance is the same thing as rate times time. So I'm going to represent my distance as 35t and 45t. And then I know that they went a total distance of 160. So this here kind of becomes the equation that I'm working with. All right, so I have 35t plus 45t equals 160. So I get 80t equals 160. So t is 2, and that would be 2 hours. All right. So it'll take them 2 hours until they get exactly 160 miles apart from each other, right? And that could be, I mean, you can figure out, like how far each of them are. Like if we put 2 back in here, right? 35 times 2 is 70, right? So the T-mid went 70 miles. And then if we put it inside here, 45 times 2 is 90. And so Felipe's went 90. So that's how the 90 and the 70 is split up in that 160 miles. Okay. All right, let's look at number 3 also. But please speak up if you have some questions. It really will help a lot of people too, because everybody, kind of has a great way of explaining things, and just if you can say, oh, well, I think about it this way, it might help a student in the class, right?
Number 3 was really confusing to me.
Okay, so where was the confusion starting to happen, or what were you getting confused by? Can you identify that?
Yeah, because it says like h of t is 0,
Mm-hmm.
so I didn't know if I plug the 0 in for t.
So notice that it says, like the question is, when will it hit the ground, right? So it is confusing because in the question it tells you that it's starting at t of 0, or t equals 0, which I'm not quite sure why it's, saying that. I mean, you can't have negative time, and, so it just makes sense that time would start at 0. But the part that you need to notice is when it says, when will it hit the ground? Because that is asking, when is h of t 0? Right? Because remember, h of t, this is the height, right? And this is the time at a given height, right? So the time in seconds, right? So you can figure out, at 3 seconds how high the rocket would be in the air, right? Or if it was, 5 seconds or whatever, you could plug those in for t and figure out what the height is, right? But we're trying to figure out, when is the height 0? So when is h of t 0? So we need to put 0 in place of our h of t, and then solve it from there. So I can see why sometimes, the wording of it and stuff can be really weird, but when you're looking at the question, right, when will it hit the ground, right, that's how you know that you're going to let h of t equals 0 and then solve it.
That makes sense. Okay, that makes more sense.
Yeah. And so then from here we can factor out, right, a greatest common factor. And so that negative 16 will actually factor out of everything. And remember, if that leading coefficient is negative, you want to take that negative out with it. It'll just make the rest of the factoring easier. And so, let's see, 144 divided by negative 16 would give us negative 9t. And 352 divided by negative 16 give us negative 22. Right? And then let's factor this trinomial. So t times t is t squared. What times what is negative 22? That adds to be negative 9. Well, I know 11 times 2 is 22. And if 11 is negative, 2 is positive. That will give me those things that I'm looking for. All right, so then remember, you're setting each part equal to 0, but that negative 16 doesn't have a t to solve for. So you're not really setting that part equal to 0. You're doing a t equals 11 equals 0 and t plus 2 equals 0. And so here we get t equals 11 and t equals negative 2. Well, can we have negative 2 seconds? Right? That doesn't make sense that the rocket's going to hit the ground 2 seconds before it takes off. Right? So that one we have to disregard. It's an extraneous solution. So that means that 11 seconds could be our only answer for that one. Okay, did that help?
Yeah, so then we just do nothing with the negative 16. It's just there.
Yeah, because if you try and do negative 16 equals 0, do you see there's no t, there's nothing to solve for. Negative 16 doesn't equal 0, so it's just kind of a nonsense statement. We don't need to do it. If it said negative 16t, right, if we factored out a t also, then you'd need to set it equal to 0, because then there's something there to solve for. Does that make sense?
Yes, it does. Thank you.
Yeah, you bet. All right. Other questions there? I hope that that was helpful to kind of go through a few of those, because like I said, I mean, these 3 questions could definitely show up on the final exam, and so I want to make sure that you're feeling really confident about those. And so if you have other questions on the exam that you want to look at, right, coming to my office hours would be a great time to talk about those things more individually, or just setting a time with me. Okay, I'd love to help you with it. All right. But yeah, overall, I just wanted to tell you guys, you know, there was really good scores overall on the exam. So, you know, way to go on that. And, you know, I just want to caution you, because we just found out, you know, that they are going to be, you know, proctoring the final exam. And I wish they would have had this figured out before the semester started, because I don't like that the department's like, yeah, let them use their notes, you know, and stuff. You know, I mean, they left it up to the instructor to use the notes on the, you know, the exam 1, 2, and 3. But then they're saying, you know, no notes on the final exam. And it's going to be proctored that way. I mean, that, I guess, could change because things keep changing. I know that there's been a few students from other 1010 classes that have kind of reached out to the department chair asking, you know, her to, you know, just, this is the way they've been taking the exams in class, and, you know, but I don't know what's going to happen there. So I know, and I know it stresses you guys out with no notes. They just are like, well, in the past, you know, we've never let students use notes on 1010 exams, and so we should, you know, just keep going with that. But I feel like this is kind of a different time. It's like you guys are learning in a different way than you're used to learning to, you know, like, so anyway. But I wish I had more say in that. I just have to go with what the department says. So I guess really the only way to kind of, I don't know, maybe to get that changed would be to reach out to the department about it. So yeah, I mean, so Suzanne Mosdy is the associate dean. If you look up like math department on SLC's SLC's web page, you know, the math department, she's the associate dean that kind of makes those decisions. So, okay. All right. And like I said, it could change, but the word I got last week was, you know, that we're now going to be proctoring them, you know, live, unless you have you know, unless you're high risk, and then you're going to be using a proctoring system where it's kind of like a webcam is watching you while you take the test. So, so that's kind of the two different options there. Anyway, so yeah, just to maybe just throw that out there, let you know. All right.
On that, while you're talking about it,
yeah.
Is it so we schedule our own time to go do it, or is there one designated time that we go in and take it?
There is going to be one designated time to do it, is how they're saying right now, because when you signed up for this class, right, it was, you signed up for, you know, Monday, Wednesdays from 2 to 5 p.m. So basically your final exam time would be either Monday, or it's going to be on Wednesday. It'd be Wednesday from 3 to 5 p.m., I think.
Okay.
So, but yeah, well, I'll give you more information about that. But they assume since you signed up for this time that you could come at that time, since you're supposed to be coming to class at that time anyway. So that's kind of how that's going to work.
Okay, yeah, I didn't know, because I've heard from one of my other classes they just didn't want to like crowd the testing centers. They kind of wanted to break everybody up.
Mm-hmm. They're going to be putting us, so they're going to, like, you guys won't, you know, we'll be taking it in a really large classroom, you know, like one of like the lecture rooms or something, not, but like that holds, I don't know, like 90 students or something like that, to make sure that there's enough, you know, social distance and stuff between everybody.
Okay.
So, yeah. So I know this is all just craziness, but guarantee I'm going to help you guys get there and stuff. And I think if you're following those things that I told you, you know, when we did the, you know, how to ace your math exams, if you're doing that, you know, I really think you're going to be able to do well on the final exam and stuff too. So try not to stress about it too much. I know it's hard, you know, not to, especially like with the not knowing. So that's always the hard thing. But hopefully they'll make concrete decisions really soon. But I would say just plan on no notes right now so that you're kind of in that mode of thinking of things that you need to get memorized. Okay. All right, so moving on to the 6-4, 6-5, and 6-6. I want to first ask you a couple of questions. I want to ask you, are these statements true or false? So some will be true, some will be false. All right, I want you to state which ones you think are true, which ones you think are false. Okay, so how about, so just write these down in your notes. We'll talk about it. Don't say out loud yet what you think. All right, so take a look at those 4 statements. Okay, so if we're looking at this first statement, it's saying if we multiply these radicals together separately, right? So it's like we'll take the square root of them first and then multiply together is what the left side is saying. So the square root of 25 is 5, and the square root of 4 is 2, and so that gives us 10 on this side. And then if we multiply them first, before we take the square root, so it'd be a square root of 100, square root of 100 is 10. So this is yes, right? This is a true statement. It's true here, right? Because we get one side equals the other side, just like that. Okay? So this means that we can take something that is written separately with multiplication and put it together as one radical, or the other way around. Okay? How about this second one? Well, if we do that same thing again, here the square root of 9 is 3, the square root of 16 is 4. When we add those together, we get 7. Now, if we do the adding first, that's going to give us the square root of 25. The square root of 25 is 5, so that means these are not equal. Right? So this is a false statement. We can't split something up. So if it's written inside the radical like this, right? Everything's underneath the radical. We can't just split it out into two different statements connected by an add sign, right? You don't get the same thing. Okay? So true for multiply, false for add. Let's look at subtract now. Right, so again, if we take the square root of 25, that's 5. Square root of 9 is 3. Subtract those, you get 2. And then 25 minus 9 is 16. Square root of 16 is 4. So this one is also not equal. Right? So with subtraction, we can't just split these up into two different things. And then with division, right, so this one's saying divide what's inside first. 100 divided by 25 is 4. The square root of 4 is 2. This one's saying take the square root of them first. So square root of 100 is 10. Square root of 25 is 5. 10 divided by 5 is 2. So we do get the same thing there. So that one is a true statement. So what this is telling us is that multiplication and division, right? You can put these radical statements together or you can separate them out, but you can't do that with addition and subtraction. And I would say that's one of the most common misconceptions that I see when we're doing this chapter, is that, you know, students try and take this square root of 9 plus 16 and break it up into the square root of 9 plus the square root of 16, right? But you can't do that. So just watch that closely. You can do that for multiplication, you can do that with division, but not add and subtract. Okay. And then let's talk about maybe some different parts of these radicals, because we are going to be talking about radicals a lot here. So the number underneath, right, this root, right, is called the radicand. Right? So whatever number or expression is there, right? So a lot of times in the homework and stuff, it'll say things like, talk about the radicand, so it's important to know what it is they're talking about. And then the type of root, right? So if it's a square root or a cubed root or a fourth root, whatever that little number is there, is called the index. And so you'll hear that word used a lot. So you just notice that the index, okay, and sometimes they'll call it the root too, right? But the index or the type of root that it is determined by that little number there. Okay, so just knowing a few things about that is helpful. Okay. All right, let's look at maybe just a few examples off of 6.4, and then make sure you have any, homework questions, if you were, went through the homework and you got stuck on some, even if you were able to, finally figure it out, but, it was a struggle or you're not sure why you got that as the answer, it just, you're like, I was able to get to the right answer, but I'm not sure if I could do it again. Right? Sometimes that happens, and we want to make sure that you understand why you're getting there. All right, so 6.4 is dealing with simplifying radicals and also multiplying radicals. Let's see. Back here. So let's start off maybe looking at one like this. So if it just says to simplify, and we are given the square root of 175 y to the 9th power, right? So something like this. So remember, if there's no index shown there, right, then there's really an invisible 2 that's there. It's a square root if there's no other number shown there. And so that means everything has to be taken out in groups of 2. So a good way to figure out what gets to come out and what has to stay inside is to do the prime factorization. All right, so we want to break down 175. All right, now it ends in a 5, so I know that 175 can be divided by 5, and I'll go in 35 times. So I'll say 35 times 5, right, is my 175, and then 35 can still break down to be 7 times 5. All right, so then I can kind of see here, let me rewrite this down on this first one. So if I have the square root, I'll just write a big huge thing down here, 5 times 5 times 7, right, is my 175. And then I've got 9 y's here. And so everything has to come out in groups of 2. And so that's what I'm looking for. I see that a 5 can come out. I see a y can come out, another y can come out, another y can come out, and another y can come out. Right? But there's a 7 and a y that's still stuck inside that square root. They don't get to come out because they don't have a pair to match up with. Right? So coming outside, right, we've got 5. Remember, you have to have 2 of the same in order for that number to come out. So a 5 gets to come out. Actually, I'm going to write it this way, just on this first one. So 5 comes out, and then each of these, right, comes out. So that means what gets to come out is 5, and then y to the 4th power. And then stuck inside my square root is my 7 and my y. And so then that would be my answer for this. Okay, questions on that? And hopefully this is looking kind of familiar to you, this, first little bit and stuff. If it was a cubed root, then you have to take things out in groups of 3. If it was a 4th root, groups of 4. If it's a 5th root, groups of 5. Right? So that root, whatever that index is really important to help you know like how you're going to be taking these out of that root. Okay? All right, so let's look at another example here. This time we have 3 times the square root of 5a to the 7th power. And be really careful. Like sometimes it's really easy to not put your square root over everything that's supposed to be inside there. So make sure you're really clear on what is under your square root and what isn't. Okay? And then times 2 square root of 15a to the 3rd power. Okay, so I want everybody to try this, right? So I want to, what you've learned in the videos and stuff like that, I want you to multiply these together and simplify them. Okay. Okay, let's see how you did here. All right, so the 3 and the 2 are already on the outside. So those guys are going to stay on the outside. So I have 3 times 2 that's already out there. And then I'm just going to write what is inside right now. And instead of doing my 5 times 15, because then I'm going to end up having to break it down again, I'm just going to go ahead and break these down to their prime factorization already. So there's the 5 from the first one. 15 breaks down to be 5 times 3. And then I can see that I have a to the 10th, right? And so I can see that what gets to come out as far as the numbers go, right? It's a square root. So a 5 gets to come out, right? And then I didn't write these all down because I don't want you to get in the habit of having to, do it this first way that I did by writing out everything. Because if you have like x to the, 35th power, you don't want to have to write down all of those, right? Remember the shortcut for this is you're saying, 10 divided by 2 gives you what? And that's 5 because you're trying to figure out how many groups of 2 are there in that. So a to the 5th is what gets to come out on that one. Okay. And so then remember, when something comes out of the square root, it's going to multiply with the numbers that are already out there. So I've got 3 times 2, which is 6, right? And then 6 times 5 is 30. So that's how I get this 30 out there. I'm doing 3 times 2 times 5. Okay. And then also an a to the 5th comes out. And what is it that's left inside?
3.
Yeah, just the 3. There's no a's, right? Because there was an even amount of groups there. So only the number 3 is left inside. And so that would be what you get for your answer on that one. Okay. Questions there? All right. Let's see. I mean, usually this, 6.4 people have kind of seen before, or, maybe a little bit easier to figure out. So let's move on to 6.5, because I would say 6.5 and 6.6 are where there are usually more questions. And on 6.5, we're going to be talking about dividing radical expressions. And we'll also be talking about something called rationalize. Oops. All right, how to rationalize a denominator is what we're going to usually be doing on something like this. Okay, and that's what happens when we're, when it's saying to divide a radical expression. That's really what's happening there. So let's start off looking at one like this. So if it just says the directions are to simplify, and you're given this So everything's inside the square root here. So I've got 16x to the third on the top, and then on the bottom, y to the 8th, right? But notice this whole thing is inside the radical. Be really careful because oftentimes I see people write this down when it really meant this, right? You've got to be really careful that that radical is covering everything that you mean for it to be inside of, okay? So those two things do not mean the same. All right, so it's, so we're trying to simplify this, right? And so one thing that we can do is just try and, you know, take out the things that we can on the top and on the bottom, because remember, we could rewrite this instead of being one big radical, right? We just got done saying up above how we could take a division expression like this part D, right, and split it up into the numerator and denominator with the radical. We can do that with division. So let's go ahead and do that on this one. It might make it a little bit easier to figure out. So I've got 16x to the third inside the square root, and then on the bottom, square root of y to the 8th. All right, and so we'll just focus on the top. Well, what can come out of the top? Well, the square root of 16 is 4, so 4 gets to come out. And then x to the third, right? So remember, this is a square root, so things have to come out in groups of 2, right? So if we're thinking x times x times x, 1x gets to come out because there's a pair of them, and then 1 is still stuck inside. Okay, and then on the bottom, right, remember there's 8 of them. How many pairs do we have there? Well, we'd have 4 pairs. And so everybody gets to come out on that one. And that's how you would leave your answer for that. Okay, so it's connected by division. Sometimes it's best to split those into 2 different things and then, simplify the top and then simplify the bottom. Okay. But sometimes if it's written separately, we might want to, put that back together. That could be, helpful for us. So meaning if we had something like this, let's say 72 xy is inside the square root, right? And then all over 2 square root of 2. Okay. So if I was to write this back as one radical, right? Notice that this 2 on the outside, right? It can't go back inside the radical. It's already outside, okay? And one comparison that I've made in the past that kind of helps students, and I think it just helps them to, think about it, is just, thinking about, like this is like inside, square root, prison, and then, or this is the outside world, right? So, so in jail or in prison and then outside and stuff, right? And so if you're already outside, you're not going to want to go inside, right? So you're not going to go in there. But this 2, this one is already inside, right? So I could rewrite this as, so I could have this 1/2 out in front, right? Because that's that 2 that's on the bottom there. And then inside, I'm kind of write it like this. And then inside there, we've got the 72xy over 2. All right, now why would I want to do this? Well, when I was looking at this, I was thinking to myself before I put this together, if I do 72 divided by 2, is that going to simplify? Like, is it going to give me a perfect square or something that I can simplify easier? And it does. That gives me 36. Right? So here I'd have 1/2 and then times the square root of 36 xy. Right? I just did that 72 divided by 2 to get that 36. And then I can see the square root of 36 is 6, so that gets to come out. So I'd have 1/2 times 6 that gets to come out. And then my x and y are still stuck inside. They don't have a pair to be able to get out, right? And then I just need to simplify on the outside there. 1/2 of 6 is 3. So 3 square root xy would be my answer on that one. All right, so sometimes it's going to be better to put it together as one radical so you can do the division first. Right, but only if it's going to help you. Look up at the one before, right? It wouldn't help me to keep this as one radical because there's nothing I can simplify inside there that's going to do me any good, right? So that's why I wanted to split those up. Is that clear? Like how to be able to tell when we want to put them together and when we want to, you know, keep them separate? Yes, no, maybe, thumbs up. Okay. Some of you are at least responding, so sounds like that's good there. All right, let's go and talk about rationalizing denominators now, because that's going to be a big part of what you're going to need to understand how to do. Let's see. So let's do like this. So if it says rationalize the denominator. So first of all, let's make sure that we understand what these directions are saying, because you're going to see these directions a lot. All right, so if it asks you to rationalize the denominator, that means that you are getting rid of any roots in the denominator. So get rid of any roots in the denominator. And they could say rationalize the numerator. However, that is less likely to happen, but they could ask you to rationalize the numerator, and that just means get rid of the roots in the numerator, right? But usually what we want is no roots in the denominator. Makes it easier for things that we're going to be doing going forward, like solving it and things like that. Okay, so that's why we need to know how to rationalize these. So if I have, let's start off with one like this. So if I just have the square root of 4 over 5 times the square root of x. Well, I could go ahead, so this is just the question to start off with, right? And I could simplify on the top, square root of 4 is 2, right? So I'd want to simplify that first. If there's anything in there that could be taken out of square roots or, you know, any way that you could do any simplifying. So look for that first, right? So I'm just going to put simplify first. Okay, then you'll want to rationalize the denominator. Well, and we'll want to think about this. How could I get rid of this square root? Well, think about, let me just do over here, if I take any, you know, like, so the square root of 3, and I times it by itself, by another square root of 3, that gives me the square root of 9, which is 3, right? So whenever we take a square root and multiply it by itself, it gives me a perfect square, which will give me a whole number and no longer have a radical there. Okay, so on this next part, so I'm looking on my, you know, on the denominator here, and I'm saying if I multiply that denominator by a square root of x, right, then square root of x times square root of x is square root of x squared, which is just x. So there's no longer any square roots left on the bottom. But whatever I do to the bottom, I need to do that same exact thing to the top. Okay? And so on the top, I get 2 times the square root of x, which is just going to give me 2 square root of x. And then on the bottom, I'll have 5, and I'm going to write it this way on the first one just to make sure everybody's with me. 5 times the square root of x squared. Well, the square root of x squared is just x. Right? So, because if I did the square root of x times the square root of x, right, that gives me x times x. There's 2 of the same, so it gets to come out as an x. Right? And so that's what I'd have there for my answer. So 2 square root of x over 5x. And I know it's rationalized because there's no roots now. There's no square roots, cubed roots, no kind of roots in the denominator. Okay, let me have you try, well, better look at this one together, I think. So what happens if we have a different type of root, if it wasn't a square root? I also want to talk about how would we rationalize something like that, okay? So rationalize the denominator. And on this one, let's do this one first. So 3b cubed root of a over the cubed root of 25b c to the 5th power. Okay, so this is a little bit crazier here, right? I started off with one that was maybe a little bit easy, but I want to get to some that are maybe a little bit more challenging. So first thing that I'm going to do is I'm going to take my denominator and I'm just going to write out it in prime factorization. Okay, so I can kind of see what's happening maybe a little bit better. So on the top, that's going to still stay the same, but on the bottom, I've got the cubed root of 5 times 5 times b times c to the 5th. All right, so now what I'm trying to do this time is I'm trying to figure out what am I going to multiply this denominator by so that I don't end up with anything. Well, this time I'm trying to make perfect cubes. All right, so I need to make perfect cubes. All right. And so right now I can see that I have 2 5s, right? But remember, I need 3 of them in order for them to come out as a 5. So I can see, all right, I need to have the cubed root of a 5, right? So that will give me 3 of them. How many b's would I need to multiply this by?
2?
Yeah. Because if I did b squared times that b, that gives me b to the 3rd, right? And 3 b's get to come out just as a b. And then how many c's would I want to multiply by?
1.
Yeah, just 1, because that's going to give me c to the 6th, right? And c to the 6th is going to, there's going to be 2 groups there. So, all right, so then that's how I figure out what I'm multiplying by on the bottom to make it so it won't have a, root there on the bottom. And whatever I do to the bottom, I've got to do to the top also. All right, so let's go ahead and see what we get here. So if I multiply these together now, so on the top, I'm going to have 3b, and then I've got to multiply, right? So this cubed root of a is going to be multiplied by this cubed root. And when we're multiplying roots together, the only thing that matters is that they're in the same root, right? So they both have to be cubed roots, or they both have to be fourth roots, right? And again, if we kind of go, with the, prison analogy or something like that, it's like, maybe the level of prison they're in or something, right? The people in the maximum security, right, are in one area, minimum security are in the other area, right? So they're in different areas. So these guys would be in the same area. So I can multiply those together. And so inside I have 5ab squared and c, and make sure that that radical goes over the top of all of it. And then on the bottom, on this one I'm going to show you have it multiplied all together so you can maybe see a little bit more why we did this, right? So I have 5 times 5 times 5, and then I've got a b to the third and a c to the sixth. And so this, right, so these 3 5s get to come out as a 5. This b to the third comes out as a b. Remember, I need 3 of the same in order for those to come out. Whoops, what did I do there? It's to come out as a b. And then this last one, c to the sixth, there's 2 groups, so that would be c squared. All right, so that's what I end up with now on the bottom. So remember, I don't want to have any kind of root left down there. Right? It doesn't matter if I have roots on the top, though. Okay, and like I said, be careful what you're saying is inside those roots. Was that very tricky to figure out when you guys were entering things in? Those of you that have kind of done some of this assignment?
No.
Okay. You didn't have to put like weird parentheses or anything like that?
Sometimes you do.
Can you think about when it was having you do that, or what?
I think on the ones on, like, when they're like binomial, when you're adding them.
Mm-hmm. Okay, yeah. And we'll get to those kind. That's in the next section. So, okay, I will.
I have a question on that one.
Yeah, you bet.
Would those b's cancel out on that?
Oh, sorry. Yes, that was the next thing I was going to say, and I forgot to do that. Thank you so much. Yeah, so then after you get to this point, get rid of that part. So this isn't our final answer. Those b's, right, will cancel out. And if the 3 and the 5, like if those were, had common factors, then we'd want to reduce that fraction as well. So make sure you're always looking to reduce that. So yes, thank you very much. So this would really be our answer. But be careful, because sometimes people try and take that c squared and cancel out that c inside. But remember, that's not just a c inside. That's a cubed root of c, which is not just, a regular c. So that you can't cancel those guys out. All right, but if they're outside, you definitely can. Okay, which is what happens there. Thank you. Okay, let's look at 6.6 now. And on 6.6, we're going to be talking about, it's kind of like a lot of different things, like adding, subtracting, multiplying with radicals. So let's see. Yeah, because I think the book just says expressions containing several radical terms, right? So, oh, thank you, David. Okay, can you hear me now? I'm so sorry about that. So 6.6 is just going to be talking about radical terms. All right, so we're going to be kind of adding, subtracting, multiplying with radicals. And we did some multiplying and dividing before. Remember, with multiplying, you have to have the same index. So it just needs to be the same type of root. So let me write a few of these things down. So when you're multiplying radicals, right, you have to have the same root. So we'd have to have like a cubed root multiplied by another cubed root. And it doesn't matter what's inside. However, when you're adding or subtracting radicals, you have to have the same root, right? So that same index and the same radicand. So the stuff inside has to be the same also. All right, so if I have like the fourth root of 2x, added to, let's say 3 times the fourth root of 2x. All right, so that coefficient out in front can be different, and the coefficient that's on this first one would just be a 1 if there's nothing written there. Right, so this is like saying 1 times the fourth root of 2x plus 3 times the fourth root of 2x. But notice that in order to add those together, we have to have the same index and the same radicand. Right, so everything has to be the same. So that's one of the things you got to remember about adding and subtracting with radicals. Right, so let's look at a few here. Start off with add or subtract. Our directions here, and then we're given 5 square root of 7 minus 8 fourth root of 11 plus the square root of 7 plus 12 times the fourth root of 11. Right? So we can only combine the ones that are like radicals. Right? Same root, same radicand. So I can see that my 5 times the square root of 7 plus, this is really saying 1 square root of 7. Right? I can combine those guys together to give me 6 square root of 7. Right? Notice I'm just adding the outside numbers together, and then what's inside stays the same, kind of like a common denominator, right? When you're adding and subtracting fractions, your denominators have to be the same, and then they stay the same, right? Same thing happening here. They have to be the same in order to add them together, and it stays as that square root of 7. All right, then on the other two, so I can combine these guys together as well, right, because they're both fourth roots of 11. So I combine what's together on the outside. Negative 8 plus 12 is a positive 4. So plus 4, fourth root of 11. And then that will be my answer. Okay, so I have to only, I can only combine things together that are the same. Right? And sometimes you have to make them the same or see if you can make them the same. And on the homework, if you can't make them be the same, then it tells you to put like DNE if you can't combine them together. Right? Something like if I had, 3x times the square root of 2 plus 2x times the square root of 3, I can't add those together because my radicands are different, right? What's inside there. And so on something like that, you would just put DNE because it says put DNE if you can't combine them together anymore. Usually on something like that, It's kind of weird that it just tells you to put D and E, because usually you just write it out the same. It's just you can't combine the terms together anymore. Okay, but just make sure you notice those directions and what it's telling you to do if you can't combine them together. All right, what about one like this? So if you ask you to simplify this, right, and then we have 3 square root of 45 minus 8 square root of 20. Okay, let's see. What do you mean exactly, David?
Like, on the previous one, would it be wrong if you did like 4 through 11 plus 6 square root 7?
No, yeah, that's a good question. So it won't ask you to really put these in a descending order. So yeah, either way is going to be just fine. So, and there's not one, you know, I wouldn't say there's one way that's better than the others either, but you know, you can kind of figure out a way that's nice for you. If you like to start with the higher roots and go down, you could do that. Yep. Okay. So when we're looking at these, we look at this and say, well, I can't subtract those because the radicands aren't the same. But then I look closer and see, oh, I actually could break these down though, right? So if I do the prime factorization of these numbers, this would be 9 times 5, and then 9 breaks down to 3 and 3. 20 is 4 times 5, and then 4 breaks down to 2 and 2. All right, so if I write this out, I really have 3 times 3 times 3 times 5 on the inside, minus 8, right? And then 2 times 2 times 5 on the inside. And so I can see, all right, a 3 gets to come out on that one, right? And then a 2 gets to come out here. And remember, when they come out of prison, right, when they come out of these jails, the first thing they want to do is multiply, right? So that's how you're going to remember that it's multiplication. That's what you're doing when they come out, right? First thing they want to do is multiply. Get it? Okay. Let's try that then. So 3 comes out, multiplied by the other 3 is 9. And then square root of 5 minus 8. 2 gets to come out. And you're multiplying. 8 times 2 is 16. Square root of 5. Now my radicands are the same. So now I can combine those together, right? And so with that, I get negative 7, right? 9 minus 16, negative 7 times the square root of 5. And that would be your answer. Okay. All right, so remember, if you can, try and simplify them so that you can add or subtract them together. Okay. All right, let's look at one like this now. So if I have 3 square root of 7 plus 2 square root of 5, that's in one parenthesis, and that's all multiplied by 3 square root of 7 minus 2 square root of 5. All right, so when we look at this, yeah, it looks a little bit crazy. There's a lot of radicals and stuff in there, but can you see it's really a FOIL situation that's going on here? We are going to be foiling these because we've got a binomial times another binomial. All right, so let me try this. So I'm going to do, so the first term, so 3 square root of 7 times 3 square root of 7, right, is going to give me, so 3 times 3 is 9, and then square root of 7 times square root of 7, right, is square root of 49. I'll leave it like that for a second, okay, just to make sure everybody's with me and seeing that you've got to multiply those together. And this is where it gets tricky, because when you're adding and subtracting, they have to be the same. But remember, right here, you're multiplying those, okay? All right, so that's our first term, and we'll simplify more in a minute. Then we're going to take the outside terms, multiply those together. So 3 times negative 2 is negative 6, and then times the square root of 7 times 5, which is 35. Okay. Now let's do the inside terms. So that's going to give me positive 6 square root of 35. And then the last terms will give me negative 4 times the square root of 25. Okay, and now I'm going to simplify here some more so I can see what I have. Well, notice that those two middle terms, right, are just going to cancel each other out. We've got 6 square roots of 35 and negative 6, right? So those guys just cancel out, and those are gone. On this first term, I've got 9 times the square root of 49, which is 7. Right? So 9 times 7 gives me 63. And then I still have this other part over here, so minus 4 times the square root of 25, which is 5. So 4 times 5 is 20. Right? And then when I subtract that, I get 43. So notice on this, we started off with all of these crazy radicals and everything, but my answer ends up being, you know, just a whole number. It doesn't have any radicals in it, okay? And I want to talk about why that is, because that's going to lead into our next thing, right? So these guys right here, so this term, notice how it's really similar to this. I meant factors, right? So this first factor and the second factor are exactly the same, but one has an add connecting them and the other one has a subtract. And so when we have something like that, we call these conjugates. Oops. Okay. So these are called conjugates. And the cool thing about conjugates is if you multiply them together, then you always end up with a whole number answer. Right? So there's no radicals. And so that's really an important thing to understand, right? So understanding what a conjugate is and what it does. Okay. All right, questions on either of those examples? I can help clarify more.
Can you say again what conjugates are? They're just the expression?
Yeah, so look at what I have boxed in pink. So notice that that first factor that I have boxed in pink is, you know, almost exactly the same as the second one, except one is connected by plus and one is connected by minus. And maybe let's look at some that aren't so crazy. Why don't I just list out some other conjugates here? All right, so like if I had x plus 4, its conjugate would be x minus 4. All right, if I had 3x plus the square root of 2, its conjugate would be 3x minus the square root of 2. All right, so they're exactly the same, except one is connected by add, the other one's connected by subtract. Does that make more sense?
Yes, thank you.
Okay, because the next thing that we're doing, you've got to understand what a conjugate is, right, in order to do what we're going to be doing next. Okay, so let's look at that one. So if we're asked to rationalize the denominator and it has a binomial, okay, so rationalize the denominator, and it gives you something like this: 5 over 4 minus the square root of 5. Okay, so in order to rationalize the denominator, remember, to get rid of all of the roots and stuff in there, we need to multiply the denominator by its conjugate. Because whenever we multiply by a conjugate, we'll always get a whole number. It won't ever contain any radicals in it. Okay, so what would I want to multiply this denominator by?
Four plus the square root of 5.
Awesome. So I'm going to do 4 plus the square root of 5. Right? And so really on the bottom, I'm going to be foiling those together. Right? And then on the top, I also need to multiply this by 4 plus the square root of 5. So you always look at the denominator first. What is it that I need to multiply it by? And then I'll multiply it by the same thing on the top. Okay? So then on the top, so if we're looking at the top here, I'm going to distribute this 5 through. Right? So I'll have 5 times 4 gives me 20. And 5 times the square root of 5 is just plus 5 square roots of 5. Right? I can't multiply something on the outside with something on the inside. Okay? Think about it. If this guy's in jail, right? This guy's on the outside, can they multiply? Right? No. Right? I guess unless you have a special kind of visit, but right? But then on the denominator, we're going to do the same thing, but we're going to be foiling these, right? So I'm going to do 4 times 4 is 16. 4 times square root of 5 is plus 4 square roots of 5. And then negative square root of 5 times 4 is negative 4 square roots of 5. And then the last one's going to be negative square root of 25. Extend that out further there. All right, and now let's simplify up here. It's on the top. There's nothing that we can do to simplify. All right, that's square root of 5. There's nothing more we can simplify there. But let's look at down here. Well, again, I can see, 4 square roots of 5 minus 4 square roots of 5. All right, go to 0. And then I have 16 minus 5, right? The square root of 25 is 5. And then I still need to get that together. 16 minus 5 is 11. Okay? And so this would be my answer. I can tell it's rationalized because there's no radicals left in the denominator, right? And the way that I do that is if I start off with a binomial, remember binomials have 2 terms in them, right? So I have to multiply by its conjugate, right? And that will get it so that I just have this whole number answer on the bottom. Okay. Questions there? Okay. So David asked earlier for something like number 16, excuse me, on the homework. And so I'm going to do one that's kind of like that. And it gives kind of some like strange, directions maybe, and not, and so let's talk about what these directions are saying. So it says reduce the index on the radical. Right? So those are kind of some strange instructions, right? Usually we hear simplify or add or subtract or multiply or something, but reduce the index on the radical. And so if I'm given this, I've got the 8th root of 25 x squared, y squared, z squared, right? This is all inside that 8th root. Right? Well, the first thing that you're going to want to do is change, they're going to give you, either a perfect square or a perfect cube or something like that. And you want to make sure that you change that. So this one, you can see that these are all squared. So I'm going to try and change this to something squared, meaning I'm going to change that 25 to be 5 squared. Okay, so I'm just rewriting it right now, changing that 25 to 5 squared. I'll write that over here. Change 25 to 5 squared. Okay, that's all I did different there. All right, then I want to take and write this as rational exponents. So remember how we talked about before, if I have like the if I have something like this, like the 4th root of a to the 3rd power, that's also the same thing as a to the 3/4 power, right? And so we're going to be using that idea to help us simplify some of these, okay? And so on this one, I want to raise these all, so I'm going to rewrite this so this whole thing is written to the 1/8 power. All right, because this whole thing inside here, and this is where it's a little bit, you know, confusing, because these don't always have to be the same number, like the same exponents in there. Happens to be on this one, but we could say that they're all, you know, being raised to the 1st power. So I could take this whole thing and say it's being raised to the 1/8 power. Okay, is everybody with me there so far? No, this one's kind of a strange one. Okay, so I just changed that 8th root to the 1/8 power. Okay, now I'm going to distribute that 1/8 power through to everybody. All right, so I have 5, and then 2 times 1/8, right, is going to be 1/4. So now it's really 5 to the 1/4 power, x to the 1/4 power, y to the 1/4 power, and then z to the 1/4 power. All right, so do you see how I have ended up reducing this? So it used to be, right, these were all kind of to the 2/8 power, right, if I distributed that through, and then I reduced them to the 1/4. And then I'm going to change it back to radical form, because if it starts off as a radical in the question, they'll want you to have your answer in radical form. So I'm going to just put here, change back to radical form. All right, I mean, this is a correct answer, you know, or that whole thing raised to the 1/4 power, right? But I'm just going to say, so really I have the 4th root of 5x, y, z. And that would be my answer. Okay, what things could I answer there?
That made sense.
Okay. Did they give you any kind of a video or?
No, not on that one.
Okay. Because there's other ways you can do it, but I think that this is usually the most straightforward way to do it. Okay. Let's look. There's a couple more I was thinking, wanted to look at, but are there other things on 6.6 homework that you guys, you know, if you attempted, but you're like, oh, I got really lost on it, please let me know. There's some, like the homework, that I can work through for you. All right, maybe while you're thinking about that. I have a couple more that I wanted to try and do with you that I think also can, please ask questions, right? I don't know. I feel so weird when you guys aren't asking questions because I'm like, okay, are they just totally lost? And, and they're like, I don't even know what you're talking about, Becky. Or you're like, I'm good. I got it. Right? So it's hard for me to know for sure. But, okay. So we're going to simplify here. But this time we've got the fourth root of 9ab to the third power, right, multiplied by the square root of 3a to the fourth b. Okay, now I just got done saying that in order to multiply radicals, right, so if we go back up here, where we talked about that, in order to multiply radicals, they have to have the same root. They have to have that same index, right? Both of them have 3s or 2s or whatever. And on this one, whoops, where did it go? On this one, we don't. We've got a fourth root and we've got a square root. So that means we can't combine them together the way they are, but we've got to make them the same, right? So that they are inside the same root, exactly. All right, so I'm going to go ahead, I think it's easiest to change these to the fractional exponents, right? So I'm just going to rewrite this so that I have 9ab to the third power, all raised to the 1/4 power. Right, so first start off by changing these to rational exponents. Okay, write that down here. So change to rational exponents. All right. Okay. Then let's go ahead and I want to look at my. So I've got a 1/4 and I've got a 1/2. But I need to make these the same, right? Same denominator, because that's really what my root is. So I'm looking to try and find a common denominator, right? So what would the LCD of 1/4 and 1/2 be?
4.
Yeah, so it's going to be 4. And so I'm going to change this, right? So I need these both to be 1/4, because remember, if something's raised to the 1/4 power, that means it's the fourth root. So if I times this bottom by 2, and I times the top by 2, then that's really being raised to the 2/4 power. Okay, so let me write this out again. So this first one, nothing changed with it. Okay. But this one, I've got 3a to the fourth b. Now it's raised to the 2/4 power. All right, so now they have the same denominator. All right, and so that means that they will be inside the same root. Okay, so I'm going to go ahead and change them back to the roots now. Okay, so change back to roots. So that's going to give me the fourth root of 9ab to the third. And then this one is going to be 3a to the fourth b. I want the fourth root of that, right? But remember that we're squaring all of this, because that's where that 2/4 is coming from. It maybe make sure. So this 2/4, right, is found here, that 2 and that 4. All right, so I've got to raise everything inside to that second power. Okay, so let's do that. Let's simplify that part. So my first one, again, is still staying the same. We're not doing much with this guy yet, right? Then this is the fourth root, right? So 3 squared is 9. A to the fourth squared is a to the 8th. And then we have b squared. Okay. So now, right, finally, I have the same radicals, right? So they're the same root. And so now I can multiply these guys together, right? But again, remember, I don't really like to multiply them together and then have to break them down apart, right? Once I get these to be the same root, and I've simplified inside like I did up here, then I'm just going to put this all underneath one big fourth root, right? So 9 breaks down to be 3 times 3, right, and 3 times 3, so I'm going to break that down, so 3 times 3 times 3 times 3. Then I have a to the 9th power, right, because I got an a to the first times an a to the 8th, so I add those exponents, so a to the 9th, and then b to the 5th. Okay. Everybody with me there?
Yep.
Okay. Okay, so break down to prime factors and simplify, right? So I can see now I have an index of 4, so I need 4 of the same in order for these to come out, right? So I've got 3 that can come out, right? With my a to the 9th, right? Remember, I'm dividing that in. How many times will 4 divide into 9? Well, it will go 2 times with 1 left over, right? So I'm going to write it like this. So a squared gets to come out, right? Because 4 divides into 9 2 times, and then there was still 1 a left over that's going to be inside. So I'm just going to put it up here so I remember about it. And then with my b to the 5th, right? 4 divides into 5 1 time, so just a b gets to come out, and then there's a b left over, right? That has to stay inside. So these are my guys that get to come out, right? And then these are the ones stuck inside. Okay, so when I write down my answer, don't forget about your fourth root. It's so easy to leave off that index there. So I've got the fourth root. Let's see, whoops, I meant to put these things on the outside first. So 3a squared b, right? And then all that's left inside is just ab. Make that a really long square root there, the fourth root. Okay, but that would be your answer. Okay, I want you guys to try one kind of like that so I can see, you know, maybe where you're at with this. I'm going to give you one that's a division one, but remember the same thing is true. It doesn't matter if it's connected by, you know, multiplication or division. They have to have the same root, okay? And so I want you to try this one and see if you can relate what we know in that last example to this one. So how about if we have the square root of ab to the third, right? Just b is to the third power there. And then on the bottom, I've got the fifth root of a squared b to the third. Okay, so go ahead. See what you think you do here. Give you a few minutes. Try it out. Okay, you may not be done with it, but hopefully you've got a good start into it and could see maybe, you know, if you were getting stuck anywhere or if you were on a good roll and were doing good with it. But let's go ahead and talk about it together. So the first thing you need to do, right, is these guys have to be the same index, and they're not right now. So I've got to get those to be the same. So I first changed them to rational exponents, and then I found what that common denominator was and put those on there, and then now I'm going to change it back to radical form, right? So I'm going to have the 10th root on the top of ab to the 3rd all raised to the 5th power. All right, so all that stuff inside is raised to the 5th power, but I've got a 10th root. On the bottom, again, I've got a 10th root, right? That was the whole idea. I was trying to get those roots to be the same, so I'd be able to subtract these. And then I've got a squared b cubed raised to the 2nd power, right? So that whole thing inside is being raised to the 2nd power. Okay, now I'm going to simplify by distributing those powers through. So the 10th root of a to the 5th, b to the 15th, right? Remember, a power raised to a power, you're multiplying those together. And then on the bottom, I've got the 10th root of a to the 4th, b to the 6th. Okay, what from here? Right? How many of you were able to get to this point at least? Click the hand raise button if you were able to get there. Okay, looks like quite a few of you did. And if you didn't, hopefully you see what you need to do to get there. And I know I kind of went quick, so I'm not expecting you guys to be done with this one by any means. But anybody have an idea of what they would do at this point to finish simplifying this? What could we do?
Would we just divide those? So like take a to the 5th, subtract a to the 4th?
Yeah, so I would first put it together as one big radical to, you know, to make sure that you see that you can do that. Since these are both the same radicands, you can do that. And then, like you said, then it's just kind of combining things together like we did before with our properties of exponents, where you were saying subtract those exponents from each other, right? So I'll have the 10th root, and then if I look at my a to the 5th and a to the 4th, that just gives me an a. And then my b to the 15th and b to the 6th, what is that going to give me? Whoa. B to the what?
Ninth.
Yeah, you guys with me? All right, we subtracted the exponents there. 5 minus 4 gave us a power of 1, and then 15 minus 6 gives me that power of 9. Right, and then there's nothing left in the denominator anymore, right? So this would be, well, it would be my answer, but I also would want to look for one other thing. You know, if, say that this last one was like b to the 12th power, well, then I could take out, right? There would be a group of 10, right? Since it's a 10th root, that could come out. So you'd want to look and see if there's anything more that could come out. And there's not on this one, so you are done, right? Because we've got just to the 1st power and to the 9th power. So there's not 10 of anything.